Good evening. I'm Chris Brown, the Acting Director of the Smithsonian's National Air and Space Museum. Welcome to Envisioning a World of Space People, the 18th Annual John H. Glenn Lecture on Space History. Tonight's program is made possible through the generous support of the Boeing Company. Since we started this lecture 2 decades ago, we've talked to inspiring people, celebrated exciting milestones, and explored important topics. So it's only fitting that this year's lecture takes on a pretty big question. What's next for humans in space? We're pleased to be joined tonight by a woman whose job it is to think about such things. Kathryn Lueders is the Associate Administrator of NASA's Human Exploration and Operations Mission Directorate. She's going to talk about her career revolutionizing NASA's approach to human space exploration. Now, I'd like to turn it over to Dr. Jennifer Levasseur, one of our space history curators, to share more about tonight's program.
Thank you, Chris. Kathy Lueders, tonight's John H. Glenn Lecturer, is no stranger to paving the way for women at NASA. Her position as the first female Associate Administrator for the Human Exploration Operations Mission Directorate puts her at the forefront of the United States' effort to make space a home for humans. From the Space Shuttle program to commercial crew capabilities, from the International Space Station operations to going back to the moon with the Artemis program, Lueders demonstrates qualities that show her personal investment in spaceflight activities. For her, the idea of making spaceflight accessible to more people is about both imagination and the people who support making it happen. Though she grew up mostly in Japan, Kathy completed her BBA at the University of New Mexico in 1986, with an eye towards the financial world. But her problem-solving nature led her to industrial engineering in graduate school, and soon after, NASA. She began her NASA career in the desert Southwest at the White Sands Test Facility Depot, where parts of the shuttle's maneuvering systems went to bake in the sun to rid them of toxic fuels used on missions. Even parts used on our very own Discovery passed through the facility. She later moved on to space station work, managing integration for commercial orbital transportation services and then commercial resupply services. And while the shuttle program was ending, Lueders stayed at the forefront of NASA's growing effort to expand commercial opportunities and became head of the Commercial Crew Program in 2013.
1, 0, ignition, liftoff of the Falcon 9 and Crew Dragon.
Her commitment to this new path paid off with the success of the SpaceX Crew Demo 2 mission in May 2020. Barely a month later, she headed to Washington, D.C. to take up her current assignment. Lueders is recognized across NASA, the government, and in the spaceflight community as a respected manager and dedicated public servant. She has often compared the teams needed for large projects to a puzzle. The pieces may look different, have complicated shapes, but when they come together, they create a picture of our human exploration goals. And each of those pieces is important to successful leadership. Please join us in welcoming NASA's Associate Administrator for the Human Exploration Operations Mission Directorate, Kathy Lueders.
Thank you, Chris and Jennifer. What a great introduction, and thank you to the National Air and Space Museum for having me here today. I really appreciate it. It's such an honor to be here, and when you see the group of folks that I've been following, I kind of don't know if I belong, so what an honor. You know, today, and I think the fact that I am here today kind of underscores my title, because I think when I started out, I'm not sure I would have envisioned myself as a space person. And here I am talking to you about envisioning a world of space people. I also love this picture because it shows us here on this beautiful Earth, looking at the moon, and understanding that we're using the moon for us to dream and reflect on going to Mars. And so this picture is a great picture. I think having a unique perspective actually helps us solve big problems. And I hear, you know, we've heard the famous quotes from the Apollo astronauts, but about looking back and being on the moon and looking at that small blue planet. And the administrator, Senator Nelson, talks about looking down when he was on the space shuttle and looking at the planet. And I think when we have these unique perspectives, it helps us then look at our problems in different ways. Next slide. As I already kind of gave you an inkling of, I did not start out as a space person. When I was going to school, it shows how long ago it was. I had one of my college professors in my finance class say he didn't think the stock market was going to ever break 10,000. So that shows how long ago that was. But through a circuitous path, I ended up at NASA after having a college roommate that really showed me all the interesting things that you do when you're an engineer and the problems you solve. And even though I didn't go back to school right away then, I started a new family, came back around, and realized, no, I really want to go back and become an engineer, mainly to solve problems. I ended up through a very bizarre story, actually at NASA and getting my first interview with NASA. And I always think about that this zigzag path really started with the fact that I recognized that I really wanted to solve big problems. And I will tell you, the fact that we have the missions we have set up the big problems that we have, and it's through that problem solving that makes me so excited, because when we solve problems, we're pushing and advancing the state of knowledge for us. Next slide. So, one of the big problems that I had the chance to help solve was I was in the International Space Station program, and we were really looking at the end of shuttle. And at that time, a small group of us, the Bill Gerstenmaier, the previous AA, and Mike Seppardini, the program manager for the space station program, we were sitting there thinking about how do we want space station to look like after shuttle retirement. And when you looked at the perspective of maintaining the space station with just the Russian Soyuz and the Progress missions, the kinds of science and technology we'd be able to do, development we'd be able to do at that time was going to be very limited by the transportation. And we saw an opportunity with the COTS program work that was going on. And we decided to kind of go after, I always call it that it was our Hail Mary pass, to go out with the commercial resupply services contract to see if there was a way we could entice industry to be able to develop capabilities for us to be able to deliver cargo to the International Space Station. We let the contract in December 2008. In the 2011 timeframe, we solved our first round of services to the International Space Station. I will tell you, in 2007, 2008, there weren't a bunch of launch pads. There weren't, rockets that were there and available, and there weren't spacecraft. It really was a Hail Mary pass for us. When we were getting ready to go work crew, we realized this was another big problem for us, but we had to go set things up a little bit differently. But through us moving out to solve that big problem in a different way, we also were able to begin delivery of our crew members to the International Space Station on a commercial crew transportation system. But it took us looking and solving that problem to be able to come up with these innovative solutions, and having industries help to be able to come up with those innovative solutions for us. Next slide. And look at where the International Space Station is today. I mean, we're on the cusp of doing another 10-year extension. But I will tell you, I joined the International Space Station program in 2000, and we were not envisioning how we are using the International Space Station today. I mean, when you look at the statistics that are there, and over 108 countries now being involved in the space station. We've got 3,000 experiments going on. We've got over 90 commercial implementation partnerships that we have going on Space Station. And one of my favorite statistics is 1.5 million students a year are involved in some activity that supports the space station, whether it's building cargo bags, doing experiments, talking to the crew members, doing STEM and other STEM activities. And I think all of that was enabled by the fact that we solved that big problem of what do we want the space station to look like in the future? Next slide. So we talked about the fact that I got a new job last June, and the new job, it was very interesting to me that it actually created and showed me that we have even more big problems. When you're going to the moon, guess what? You've got to solve a ton of problems. And so what's been a lot of fun for me over this last year is to go figure out how do we establish our first steps to go back to the moon. And so we've been laying out a plan, first of all, to get our vehicles ready to be able to fly our crews to the cislunar orbit area. And so the first part of that is for us to test out a rocket. So our Artemis 1 mission is coming up. We've got our uncrewed demonstration mission. It's going to be a 4 to 6 week mission. The spacecraft's going to do, go 45,000 miles farther on the dark side of the moon than we've ever been. And we're going to use that mission to really check out our systems. And then the second mission is going to be our crew demonstration mission. We've got 2 crew members going up. And we'll be able to then check out our crew transportation systems and make sure that we've got the Orion spacecraft, the SLS rocket, and all of our ground processing and flight system operation systems ready to go for us to start working our next sequence of missions, which are going to be the gateway, the initial gateway missions, and then the international partner assembly missions. And in parallel, we'll be doing our first human landing system demonstration missions on the moon. And all this we've just started to lay out and doing all the operational planning and work to go and execute those missions. Where we have some of the problems solved. We're going to need even more of the problems solved. And I'm sure there'll be other problems. I've been working development for a really long time, and I'm sure other problems will be coming along the way for us to be able to work through. What's been really key is that we have to really think about how do we get these systems set up to make sure that we're establishing capabilities that will get us ready to solve the key problems for how are we going to get ourselves ready to be able to go to Mars? And so that's why you see the planet right there in the corners. We're always thinking about how does this mission help us learn something that then will help us solve what is you want to talk about a Hail Mary pass. Going to Mars right now is a Hail Mary pass, but we got to go thoughtfully buy down the risk for us to be able to accomplish that mission going to Mars. And so next slide. So the next slide is an important piece of that. Us having a cislunar gateway, which will be going around and buying down risk and getting us ready for the orbiting portions of a Mars mission and helping us learn about aggregation, helping us learn about timing of mission, helping us learn about how to work logistics supplies and being able to have a team of people be able to maintain a capability while at the same time getting ready for crewed missions that will be coming in and performing different aspects. At the same time, getting ready to do lunar surface activities. There's multiple areas where we need to be able to do testing in different gravity fields to be able to have us make sure that we can take care of our crew members who will be being on a long-term transportation time frame and then having to go to Mars, work in an orbital gravitational field, and then go on the surface and be able to take care of themselves before they go and start doing the space technology work and the research that we want them to be doing on Mars. So we've got to lay all this out. There's lots of different parts of these missions that we don't have figured out, and we will need help from lots of different people out there for us to be able to go figure out how to really go make this work. And through that learning, we once again will be expanding, the scope of human knowledge as we work through those problems. Next slide. So people ask me a lot about, why humans are, and I'll tell you, I work a lot with Thomas Zuberkin, who's our science mission directorate. And we have this term that we use a lot about bots before boots, because there's really this partnership between our science missions and technology missions that help us learn and buy down risk about either the technologies, but also help us learn about the environments and the key aspects of the environment and different critical features that then help us better be able to prepare ourselves for the missions that have humans on them. There's a ton of learning that has to go into making sure we can create the capabilities that need to be able to keep our humans safe. And understand enough about the capabilities that we can develop technology mitigations to be able to deal with that, or operational controls. And so all that takes us being able to learn. We learned from Perseverance when Perseverance was working so hard on collecting its first sample. Thomas called me up and said, "You know what? If I only had a human there, they would have been able to scoop up the sample and put it in the volume, and we would have been able to store that sample right there and been able to go on to the mission." But so there's these capabilities that humans have, just like it would have been really nice to have had somebody there to scoop it up. But there's also this capability that humans have to be able to, when they're in the environment, be able to expand the capability and understand the key features and understand the technology that's there. There's a great story about Jack Schmitt, because he was a geologist. He was able, when he was on the moon, to understand, oh, hey, this is a very unique sample. This is a unique capability. And because he was a little bit different than the other folks, we had recognized we needed to have different skills, different capabilities that are there. He was able to really expand the capability of that particular mission. It's one of the reasons why when we are working and building our Artemis crews now, we are trying to go look at this vast group of folks out there that have different skills that we've learned have really helped us gain the capability and the toolkit for those crew members to be the right people to go explore at the next level. Okay, next slide. So what's been really neat about this is as we continue to solve the problems, sometimes it takes us a little bit longer than we want, but it's through that process of buying down that risk and continuing to learn about how to build big tanks, right? I mean, we're right now getting ready to put the Artemis 1 vehicle together, and we are learning so much. We learned so much just about how to weld large tanks. It's actually what's helping a lot of our commercial providers now know how to weld large tanks. We're figuring out right now how to go stack and get this large rocket ready to go. All that learning is going to go into then how do we be able to build these kinds of large vehicles that will help us, and for the many, many, many years we have going forward, and the larger capabilities that we're going to need to be able to go to Mars and do our other missions going forward. I've already talked a whole bunch about the International Space Station. I always have to have the pictures there of the first all-woman EVA team. And I also want to point out at the bottom, through us doing these missions, some of the problems that we're solving aren't just the technical problems. We're also solving problems about how do countries work together, and when we go to new destinations, how do we have to figure out how to work together and establish new rules of engagement for us really to be able to explore these new areas. And so the Artemis Accords is one of those maybe not the sexiest thing to be out there, but it's a very important agreement that we have that is really establishing and beginning to establish our international partnership for our activities on the moon. Next slide. So I just want everybody look at this picture, and I tell people when I go talk to lots of folks, and I tell them exploration is a team sport, and the problems we have need every single one of you out there help for us to accomplish this mission. I can't underscore it. It's through the new thinking. It's through looking at problems in a different way. It's through us being able to get a different perspective and recognize that we may have solutions in different spaces, that we will need all that talent for us to be able to solve the big problems that we have in front of us. And so I would really like as many team members on the sport as possible. We need to have team members. I need very, very young team members on this. And so I tell children a lot. I said, right now we're doing the work that are going to allow you to be wearing the boots on Mars. And I won't be wearing the boots on Mars. You'll be wearing the boots on Mars. You'll be wearing the boots on the moon. And so we need everybody out there, and this is a call for help. We need everybody out there to recognize that you are a space person. I tell companies that are out there, I need you to recognize that you may not think you're a space company right now. I want you to become a space company. You need to recognize you may have solution space with what you're doing now to be part of the space team. And I know that for us to solve these problems, we need international members on the team. We need industry members on the team. We need all kinds of thinkers on this team. And we will need a big team of space people for us to be able to get this job done. So I really thank you for your time today and appreciate the opportunity to be here speaking to you.
Thank you so much, Kathy, for that wonderful talk. I think we're going to have lots of really energized young people from that call to action, and hopefully the idea that they could be wearing those boots on Mars. So thank you so much for that wonderful lecture. I know this is a really exciting time for NASA. I know working at the museum, we get lots of questions all the time about all the exciting things that are happening right now in spaceflight, and I'm excited to be able to ask some questions from some of our viewers at home. And so if you have questions that you'd like to ask the Associate Administrator, please feel free to put them in the chat function so that we can get those in the queue to be asked. So I'm going to start off with one that's kind of a big overarching question, but I think it gets people sort of thinking about your current role and sort of, how you look back on your career and the path that you've taken. You've had lots of roles at NASA and in spaceflight, and you've been witness to a lot of very incredible moments. So do you have any one particular moment that's your most favorite or most memorable of those?
When Bob and Doug came through the hatch, I think that was I was sitting there with their wives. And so I actually had, after we launched them, I didn't leave the control center. Actually, there's a very uncomfortable couch in the control center because I just couldn't go home. I felt like I had to stay there with them. It was my way of staying there with them while they were going through their mission. I was not going to go home. And so the next morning, I was not looking great. I love to see all those pictures people took of that morning because I'm like, I could probably lose some of those. But I got to be there with their sons and their wives and recognize that we got them there safe. Right. And so that's, to me, every day I realize the job I have means that I'm holding our crew members' lives in their hands. And that was it just underscored it for me.
Yeah, I bet that's it's probably a very emotional moment to be participating in something, and especially with young people watching and having such a personal connection, that's got to be very intense. And I know with young children of my own, they're not particular fans of me, having to be away. I'm sure those boys probably didn't enjoy it either. It's hard work doing what you do, and you're, I would imagine, away a lot. How does your family react to all of that? I mean, it's a very, it's a time-consuming job, and the commitment is big.
Yeah, I think what people don't realize is that our families are really our heroes, right? I mean, I tell that to the crew members' families a lot. They're the ones that they have to say, we've got it. We've got it. You go do your job, and we want you to do it without worrying about us, right? And so our families, my husband and my children are my heroes. And there have been a lot of times that, I've had to miss a birthday and they've been so good about, okay, well, we'll have a new birthday or we'll do things, right? And so I think people in this industry, and it's not just people in NASA, it's the folks that are out there working on all our programs. There's people that have missed, baseball games and, PTA meetings and, teacher conferences, and their families are really the heroes that they allow us to do this, right? So I tell people all the time, I was with the crew members' families the last mission, and I said, you're my hero, because these folks would not be able to go up on orbit and be able to do what they do for us today if it was not for them. And that is just really underscored. When you show all those pictures, everybody needs to look. When you look in the museum and you look at all those people that have done things, there's these families there that should be there too, because they're really our heroes.
Yeah, and you mentioned sort of all the people that help support these missions after, and you mentioned, people getting involved in careers and young children getting involved and kind of heading down this path of spaceflight, being part of the spaceflight workforce. We get this question a lot when astronauts visit, but I'm going to ask it of you because I think it's important to keep in mind for young people that the astronauts are a small segment of the NASA workforce. What kinds of things are you seeing young people come to NASA with? What kind of backgrounds or resources or motivations or skill sets are you seeing people come to NASA with? Because I think it's hard for people to really imagine what is that path, especially if they're, say, a middle schooler who's maybe just visited the museum and seen the space shuttle. What do they do? What should they start thinking about now?
So I think what's very interesting is obviously, we say, hey, science and math is really important, but what we're also finding out is we need all kinds of skills, right? Guess what? We need really good procurement people and we need really good lawyers and we need really good, we need really good doctors and nurses and scientists. And so it's really, there's a large group of people. And I think over time, it's why I keep kind of underscoring this space person. I think sometimes people, and when you're in middle school, and when I was in high school, I did well in school, but I will tell you, when I started out to get my BBA in finance, originally, I didn't think I was smart enough to be an engineer. I tell people this all the time. I didn't think I was smart enough to be an engineer. And it took me having 2 children and finally going, you know what? If I'm smart enough to have 2 children, I'm going to be smart enough to go back to school. And maybe it's just going to take a lot of work for me to get through calculus 3, but, organic chemistry and a few other things. But I'm going to go figure out how to go do this. And if I can raise a 3-year-old and a 1-year-old, I can figure this one out. So don't count yourself out. That's what I tell people. I didn't start working for NASA until I was 28 years old. So don't count yourself out. Don't go say, I'm not a NASA kind of person. Guess what? It could be exactly what we need at that time. We need people that are thinking and solving problems. And the way, if you look at the way innovation's done, it's usually somebody coming in that didn't know anything about a problem and says, hey, why didn't you do that? And then all of a sudden the aperture just opens. So what I tell people is, don't say you're not a space person. Please don't say that. I would not have called myself a space person, and now I am. So I'm like the perfect example of that.
Yeah, I can really identify with that, having gone through the same thing with kids. So, and I'm sure there's viewers at home that can feel the same way. I am going to take a question from somebody that's related to this topic. One of our viewers has said, I'm a college software engineer. And for those up and coming engineers and scientists, what kinds of initiatives can you think of them getting involved in now to be that space person, or to maybe start that new space company that's really going to, have a role in doing things? How do they get started?
So I think what's really cool is that we have a bunch of people trying to think about that. And what I tell people is look at the problems. What we try to have out there is, here's the kinds of problems we're having, and we would really like you to be looking for solutions, right? A lot of the companies that have been out there are, they started because they saw a potential solution for something that we need to have and started to talk to us. We are always out there in industry talking in different forums. And so there's lots of different associations out there that enable you to be able to have those kinds of discussions and start talking about what kinds of issues and how do you solve problems. But I love the fact that there's so many new companies, and where, like 20, 25 years ago, there would have been just a few. I was just at symposium, and the funnest part of it is there's so many people out there that are like, I think you have this problem and I'm going to go help you solve it. And they're out there working on how to go get there. And guess what? It's just not, there's lots of people trying to do things in space that need these kinds of solutions, right? I think that's the funnest part of the way working in NASA is right now, is that we get to work with lots of different companies that are trying to do different things in space. And so that opportunity is there for people wanting to get in aerospace to go do really cool things, not just for NASA, but also with our industry partners. And all that opens up, solution space for people to be thinking about, how can I help NASA go do these moon missions? How can I go help them solve a comm problem? How can I go help them figure out how to collect samples on the moon? How can I help them with a solution for how to return, samples back to Earth from Mars? How can we're always talking about our problems. Listen to what we're saying and say, they've got to go figure out how to grow food in space. They've got to go figure out how to exercise in space in a small area. They got to go figure out how to, do in situ resource utilization, and go work on those problems, because we need solutions for them.
Yeah, absolutely. That's a great answer. And I think it helps me transition to the next viewer question we have. Reminder, we are using the YouTube feature to get questions compiled for asking to Kathy. And so if you have something, please do enter it and we'll get it into the queue to ask. But I'm going to segue very cleanly, I think, from your last comments to asking a little bit about what's going on right now. So do you have some thoughts? One viewer asked about, what do you see as the ultimate relationship between government space agencies like NASA and private companies or civilian space flight? There's lots of different models for this, and obviously that model has changed in your time at NASA. So sort of what do you see as sort of the ideal working relationship there?
Well, I think the ideal working relationship is we're working as a team, right? Because we've all learned over time that it's through us maximizing each other's potential that you get the best outcome, right? And so we are still continuing to refine what's the best way for us to work with industry in a way that we can get their solution space, make it clear what we're trying to get, but allow industry solution space as we're obviously trying to conduct the missions that our stakeholders are requesting us to go do. And obviously doing the assurance that we need to be able to show our stakeholders that, we have insight and oversight to be able to make sure that we're doing our fiduciary responsibilities. And we're still working through that, right? We're still working through what's the best way. I mean, obviously we've tried lots of different ways. I will tell you that the part of this that I'm kind of most proud of is that we are really trying anything that we think can work, and are really looking for industry feedback to help us with that. industry is very different. I already alluded to that before. And so we are trying to figure out how can we give as many people access. It used to be NASA was about the NASA mission. Now we're really working hard to go figure out how can I include as many people as possible, research, scientists, commercial industry, our international partners, and include them in our missions going forward. Because if we go forward as a team, that helps us really be able to push that data and all that learning that we have in a more organic way. I really feel like NASA's number one job is to expand human knowledge, right? These missions help with that. And so if we continue through these relationships, can continue to help our industry partners take the learning that we've learned from our missions and be able to share it with them, as many of them as we can, we're also really helping do that job that I feel like our external stakeholders have given us. Our job is great. We get the missions done. But I think our bigger job is to how do we make sure that learning that we've learned through accomplishing these missions, or in some cases failing at the missions, and how do we make sure everybody has access to that? That's what's great about the government is we can give it to people, right? We can share it. That gives us our great value, right? So I think we're still working on that. It's something that I would like us to continue to do is how can we become a node? How can we let people have access to what we've learned and then be able to continue to learn and continue to share that data that we learn as we're going through and accomplishing these really, really tough missions?
Well, before we transition into talking about Artemis and going to the moon, we have two very similar questions about the International Space Station, which is, of course, one of my very great interests, and I think yours as well. The International Space Station has now been a permanent home for people for over 20 years. It'll hit 21 years this November. So basically, both questions kind of get at the point of what happens next for the International Space Station. Do you see an ongoing role for the International Space Station once Artemis is up and running? They know the International Partnership Agreement expires essentially in 2024, but what happens at that, not only if that gets extended, but once Artemis is really the main focus?
You know what? One of the things that really surprised me when I came into the job is that people didn't realize we need a LEO destination to be able to test our technologies for Artemis. The space station and having something in LEO is really the place where it's the cheapest place for us really to get some of our key learning that we need to get to be able to accomplish the missions. We work a lot of, and I talk about platforms. We have terrestrial platforms. We do a lot of testing and research and analog studies and everything to buy down risk for our missions. But obviously you can't simulate, gravity. You can't microgravity. You can't simulate that here on Earth. And so the International Space Station really provides us that laboratory to be able to go take that learning and the protocols we try it on Earth, and then left there 365 days a year. And you have this database now of the medical research and the technology and the effects. We have learned so much about people through us being able to have people up there for 20 years, 365 days a year. If you looked at the medical protocols and the physical protocols we had in 2001 and the way the crew members came off the International Space Station and the way they come off now and how healthy they are in comparison because of the medical protocols and the physical and the exercise protocols we have, it shows the learning that having that laboratory does. That same learning is going to be even more critical for us, and we're going to have to learn even newer protocols as we move into Mars missions. There's nothing a better analog than having a crew member that gets off after 6 months on space station, lands, and then ask them to go do a bunch of tests. because that's the kind of job that somebody's going to have to do when they go to Mars, right? And so having a laboratory like this in Leo that can expose people to those conditions and then have them come back and have us try to do some of these tasks that we would have to do if we're on Mars is another way for us to be able to check these different gravitational fields and make sure that before we go send somebody to Mars, we've done the work that we need to do to make sure that they can do their job safely before we just send them off. When we do our missions to Artemis and we do our missions to Gateway and then to lunar surface, they're not going to be 365 days a year, for multiple years. They're going to be 30, 45 days on Gateway, and then, 2 weeks to eventually we would like to get up to maybe a month on the lunar surface. But that's not the same as a Mars transit mission. And so having a destination in low Earth orbit is critical to us. It's why we are really looking at how do we transition and finish up the research we need to do on this beautiful laboratory that we have, but how do we then really start working our transition to a future commercial LEO destination where we can continue to check the data. Obviously, it won't be like the International Space Station, but it will help us still to have an ability to go check the protocols that we will need to have before we go put people on a trip to Mars.
Well, since you've mentioned the trip to Mars, I want to bring up one of our questions from the chat, and it's about some of those challenges. And I know some of the research that's going on right now in this respect on the ISS and on the upcoming Artemis 1 flight. First, I want to ask about what are the solutions, or are there emerging solutions that you're seeing in terms of protecting astronauts from the intense radiation on the way to Mars and back?
So I think one of the coolest things on Artemis 1 is we're not flying human crews, but we're flying, people don't like to use the term dummies, but it's basically instrumented dummies. And guess what? On one, we actually have one of our experiments is a radiation vest. So we can actually have, the best scientific experiment is to have we got two dummies sitting next to one that actually has mitigation designs on it and one that doesn't. So we can actually get this direct data from the flight and the actual environment. This is the first time we've been able to get this level of fidelity, and these, the anthropomorphic test dummies are highly instrumented data sets will provide huge data sets for us to really be able to understand, which parts of the body are getting the most exposed, which ways can we be able to mitigate that kind of exposure, and also understand where we're in those areas and on the far side of the moon, what kind of environment are we really seeing? As you know, every single ounce is precious in space. And so if we can really, really understand the environment and fine tune our mitigations for the environment, so don't have to add, another 100 pounds of shielding or something else, that's very, very, very valuable for us. And so these missions will be a great source for us to be able to collect data. When we're already on Gateway, some of our first experiments that we'll be flying on Gateway are to help us further understand the solar environment and the existing other radiation environment of that area too. So it's another place where understanding the science and the exact conditions that you're operating in help us then to develop and fine tune our mitigations, because we're always making trades. We're always making sure that the things that we're flying are actually going to buy down the risk.
So to bring us kind of closer to the close, I have one fun question at the end. I always like to end on a fun one, but I do want to ask one more question about Artemis. I know, having grown up in the 1980s and watched the shuttle missions, there was lots of excitement even amongst, my friends about the idea of going back to the moon and Mars. We weren't alive for the Apollo landings. And so we always kind of wondered, when is this going to happen again? And there was all kinds of inspiration and excitement even then about this possibility. What makes you most excited about the Artemis program, especially Artemis 1, which I know is just over the horizon here?
Yeah, I think it's about having that seminal moment for our youth, right? I when I used to be with Jim Bridenstine, he was like, I'm the first administrator that doesn't remember the Apollo landing. And I just look at him and go, man, I feel old. I wish you would quit saying that, Jim, because I was like 5 or 6 when the Apollo landing. And so that's just making me feel old. But how did that change the world? Right? How did that change the world? How did that make people go, this is what I want to go do? And so I think the things that we do daily on the International Space Station are just that cool. But sometimes we make them look so easy, right? So we lose that seminal moment. So I really feel like this generation needs that seminal moment. And we're going to do it different this time. We're doing it with our international partners. You know, people always ask me, how are you doing it different this time? And it's like, we're doing it as a team. You know, we're flying with our international crew members. We're flying with our international partners. We're flying with our commercial partners. We're trying to fly with as many people as possible. And so this time when we fly, and the faces of the people that are going to land on the moon are going to look different than the people that landed on the moon before. And so what I'm hoping is when that happens, people see you and me and themselves in the people that are landing on that moon. And they realize it is about you wearing the boots. You wearing the boots. and it can be anybody wearing the boots. Okay? Anybody out there. Don't tell yourself, I'm not this kind of person. Anybody can wear the boots.
So, in absence of one of my colleagues, who I think would be a little unhappy if I didn't ask a question like this, I mentioned inspiration. Are there any particular non-technical books that inspired you? I know, I mentioned my generation being inspired, especially by things like the diversity. You mentioned the diversity in things like Star Trek and Star Wars. Those are, things that we talk about at the museum as really being, informative and kind of getting us to think differently. So do you have any books or shows or anything that you found particularly inspirational in that way?
Wow, that is a hard question. Shoot, I can't say Friends. That's not going to work out, is it? People, it is interesting. This will be a good one for me to remember for the next time. But it is interesting. I grew up in Japan, and so I never watched American TV until I came back, and I could never understand, how important that was for people, and people used to say Star Trek a lot, and I do think, even though the fact that they had women in those roles, I think was huge, because if you looked at what NASA looked like at the time, and we kind of had this joke in my office where we said, let's all dress up as the NASA in the Apollo era, right? And the women all showed up dressed as in high heels and dresses, and the guys, had to wear like pocket protectors and stuff. But the fact that Star Trek did have this whole diverse group of folks and you had somebody with weird ears, and hey, maybe had Asperger's syndromes, kind of thing. And people had really thought about the fact that we need to have this be a team, and that we need to have people that maybe didn't think about themselves as space people become space people. I think is pretty inspirational. I actually think in some ways, there's so many things out there about how a team makes us stronger that I think that's really been the most. What has been amazing to me in my whole career has honestly been the people in this business that maybe aren't making the most money, right? And they're just doing it for this crazy dream. We're just doing it for this crazy dream that us doing this makes us better. So I will tell you honestly, it wasn't a TV show. You know, I'd never paid any attention to space stuff before I showed up at White Sands, and I just looked around me, and here were these people that were all living this dream. And I thought, wow, like there's people here that's what they go to work for every day, is to go make life better. And that's a pretty cool thing.
Yeah, and that's a great message to end on. You couldn't have wrapped it up any better than I could possibly have thought of. I want to thank you so much, Kathy, Associate Administrator Lueders, for joining us today. It has been wonderful. I think this has obviously given people lots to think about. I want to thank our sponsor, the Boeing Company, for allowing us to do programming like this at the museum. And thanks to all of you at home for watching us. Hopefully we'll be able to bring these presentations to you in person in the future. We love to get all of you in a room together and get to experience being around inspirational people like Associate Administrator Lueders. So thank you again for joining us, and have a wonderful evening.